box, students. We're going to work on question number 20 right now. We're going to write as a definite integral, and then we're going to evaluate this limit as n approaches infinity of the summation as I goes from 1 to n of all of this. Now, in order to actually get this question done and done well, you have to understand what's in this set of brackets. And what's in this set of brackets is really a base times height situation where you're adding a whole bunch of rectangles. How many? An infinite number of rectangles. N is the number of rectangles you're adding up. Unfortunately with this here, the base is this 2 over n. And this stuff right here is the height of each one of your rectangles depending upon where you are on your interval. So, if you recall, this is f of c sub I, which is the height of each rectangle, and this over here is the base of each rectangle, which is considered delta x. So we're adding an infinite number of base times height, or if you will, height times base, height times base, height times base. So when you look at this set of parentheses that start and end right here, it's pretty easy to pick out your function. Now I know that some oogie boogie, some stuff, some group of something has been substituted into the function f, but I'm hoping you can clearly see what the function f was, even if you don't know what got substituted. The function f, and I'll say x because I'll replace that oogie boogie thing with an x, is 3x squared plus 4x and then minus 5. That would have been my original function with some quantity substituted in for my c sub I in place of x. Now, knowing that, you now know what your c sub I is. You know that it's this oogie boogie here that happens to be in the set of parentheses. So we have 1 plus 2i over n is being used in place of x in the limit definition of your integral. Then this delta x over here is 2 over n. Well, we have a formula for delta x. That's b minus a over n. And if delta x is 2 over n, and it's the same as b minus a over n, well then I know that 2 is the same as b minus a because my denominators are matching. So if my fractions equal, my denominators match up, my numerators must match up as well. Or if you like your rules for algebra, go ahead and multiply both sides of the equation by n, and you'll end up with 2 is equal to b minus a. Let me fix my chalk here just a little. Okay. Good to go. So back over here as I bounce back and forth, my c sub I has a formula for it as well, and that is a plus I delta x. You can see the I matches. And so you can see that the delta x is matching as well. We said that the delta x, which was your base of each of the little rectangles, is 2 over n. So this actually, the I and then the 2 over n, gives you the 2i over n. The 1 sitting right there indicates that the a is a 1. So from this information, we know that a is 1. So the start of our interval is a 1. Take that 1, put it over here in place of a, and 2 is equal to b minus 1. Add 1 to both sides of the equation and you'll find out that b is 3. I now know my interval goes from 1 to 3, and I know my function, so I'm pretty much done. I can go ahead and write this as a definite integral with definite beginning and end, beginning at 1, ending at 3. This is my function with respect to x. So I'm going to go ahead and write that over here, and then we'll take a minute to do the rest of it and evaluate the integral itself. So this is equal to the integral from 1 to 3 of the function 3x squared plus 4x minus 5 with respect to x. And we will use the fundamental theorem of calculus to integrate, substitute, and evaluate the rest of this problem. So we're going to integrate 3x squared. This will give me x cubed. We're going to integrate 4x, which should give me 2x squared. And we're going to integrate negative 5, which gives me negative 5x. This is the antiderivative of this function. And we are going to evaluate this function from 1 to 3. So I'm going to use my brackets really nice, and I'm going to put the 3 in first. This gives me 3 cubed plus 2 times 3 squared minus 5 times 3, close my bracket, minus, open my bracket, go through the same thing again, but this time we're going to use the 1 when we substitute in. So it's something cubed plus 2 times something squared minus 5 times that something, and those somethings are each a 1. 3 cubed gives me 27. Here's my open bracket. 3 squared is 9 times 2 is 18 minus 15. 1 cubed is 1. 1 squared is 1 times 2 is still 2 minus 5. So let me see here. 27 plus 18 is 45. Take away 15 gives me 30. And I will take an extra step right here. 3 minus 5 is a negative 2. And 30 take away negative 2 gives me 32. And 32 ends up being the area under this curve from 1 to 3. And this is actually a square units measurement as well. But they didn't give me any units of measurement, so I'm okay. I suppose I could say squared units, but I'm just going to leave it like that because I really don't know what the function represents anyway. So that is the end of this problem. And we could, if we wanted to, but we don't want to, we could like erase this whole thing and literally grind this out using our rules for algebra with foiling and distributing and combining like terms and factoring out anything with an n in it in between my limit and my summation, using my summation properties and then using my summation formulas and breaking everything down to the least possible number of n's and then taking the limit as n approaches infinity. But that is a very long process. That is the original limit definition of an integral, just like we have a limit definition of a derivative. This would be our limit definition of our integral. So we found our function. We know this whole idea. This is in the packet that I gave you that explained the summation, so you might want to look back in there, if you will. This gives you the a value of 1. Your delta x is 2 over n. Break it all down again. We're going from 1. You put your 1 for a into the formula for delta x to solve for b, and you get b equals 3. This gives you your lower limit and your upper limit that must exist on your integral. So nowhere here is that 1 and 3 really visible. The 1 maybe, but the 3 is not really visible unless you say, well, if I'm starting at 1 and I'm going a distance of 2, I must land at 3. So if you think it through, if you really understand what it means, you can get it. But this is the end of the problem, and the answer is 32. So everybody should have this written in their notes for tomorrow. All right? All right, talent out.